Next is Vladimir Vuksan, who's quite prolific with his contributions to operations tools that are used all over the planet. Vladimir, you ready to roll?
Yeah, I'm just trying to see if let's see. I guess. Sorry. For some reason, I'm having 1 sec. Let me. I guess. Oops. There's two audience. Okay. Sorry about that. So what I'm going to talk about is how backend monitoring can make your applications faster and more available. Mike did a great intro, and actually, as he was speaking, I remembered I was going to email him my slides so we don't cover the same stuff, because I do have a little bit of similar content that he, so we'll probably just browse through. But yeah, it was definitely an awesome presentation. So the question is, why do we monitor, except being freaky or but we monitor to alert to current problems, and that's where people usually start. When is the site down? When is the site slow? When is the disk out? And just basic reactive type of monitoring. Also, we want to look for long-term trends. How has our traffic grown? Is it going up? Is it going down? Do we need to add more machines or resources? And also looking. We need to look for what happened when problems arose, and what were number of Apache children at that time. Did that contribute to an issue? And just it's very good for postmortem analysis. However, in my opinion, one of the most important thing points about monitoring is that it helps us continuously improve and understand our infrastructure. And when I say understand is everybody's infrastructure is different. Some are running very high performance web services. Some are having a lot of API calls, and some are more popular during the business hours. Some are more popular at night. So it provides you with the understanding of when is your traffic peaking. Let's say your traffic peaks at midnight. That's helpful piece of information. Or what happens if you restart all your cache servers? How long does the slowness last? Because that presumably will involve some slowness. So you want to understand how your infrastructure breathes, so that you can make better educated decisions, so you don't decide at peak traffic to, I don't know, clear out all your cache, because that will bring your site down to its knees and make things really bad for you. So some of the challenges that are additional challenges that are posed by web monitoring are that people expect sites to be fast, and I would strongly urge everybody to watch. There's a link to a Velocity 2009 talk by Marissa Mayer, which is a great talk on how Google did a lot of testing to see how basically Google page performance affects number of searches, and there were some really stark results. You can even see in this table, this was from another paper that or another article on O'Reilly that was shown that if you slow down that page even for 500 milliseconds, you get 1% less clicks. I mean, okay, 1% maybe not much, but it does add up, and for some companies that could be a large amount of money. So just being aware of this information is very helpful to really kind of focus you on making performance or making things fast your priority. And you can't see the customers. So if you're in a typical retail establishment, you can just watch the customers. If they're not looking happy, then you could do something. Whereas with the website, you can't. They'll just leave and go somewhere else. So metrics are really your seeing eye dog. Will just it helps you see the world around you. So here I picked there's a lot of aspects to web optimization. So I picked the Yahoo website because they have it well optimized as far as CSS, JavaScript, and making things fast. However, in this particular example where I pulled it, 50% of the length of a request and is HTML generation. So they've already did proper things to optimize it from JavaScript, CSS end, and some of the other tools, but 50% is HTML generation. So if they're going to attack the performance, and I don't know if they can, the next really reasonable option is to figure out how to speed up HTML. And this is where you need back-end metrics. And as far as metrics, they're just the pieces in a mosaic. Some are more useful than others. And there is really not a set of metrics that will give you a whole picture, and more metrics you have, the better your resolution is. The better your understanding is, what the causes are, and most important is you can never have enough metrics. That will you will always find out, oh, we should have been monitoring I don't know, our error rates. So this is continuous process. You will probably never finish this process of adding metrics. So don't get stressed. Just start with basics. So where do we start? Mike did a great presentation on logs. So this is something very similar. This is the basic Apache log, and then you could use some of these tools to analyze the logs. First thing you'd want to do is just analyze the HTTP codes. So there's a set of standards of what the HTTP codes mean. HTTP 200 is okay. Content found, 206 partial content. Some of the most notable ones are 404 document not found, and HTTP 500s. That bad things are happening. You either have some pretty major failure in your infrastructure where either your backends are failing, something is seriously wrong and misconfigured. So you should graph it, and which helps you establish a baseline, so you can figure out, well, this is normal, and then if I see something else that doesn't look like that, that's not normal. And these are actual graph where the second graph actually shows after I got involved, after somebody said that things were going very slow. They didn't add. They were doing their own monitoring. So I actually installed a Ganglia agent to just try to get some sense of what was going on. And it was pretty much immediately obvious that there was something wrong with the number of 404 errors, and it was they pushed a bad piece of code that was. That caused issues because the file system was NFS, and then it had to parse all these htaccess files, so things were pretty slow. You should aggregate like things so that you know that when things are isolated, is it like one server that is down, couple, or is it like full site? So this is, in this particular case, this was a bad set of firewall rules that caused the the traffic to Crater. So you should, that's another avenue you could take. So that was easy. Now Mike covered the %d, which is the time to service a request in microseconds. So some of the useful metrics you would get out of it is what is the average response time for each, percentile response rates, and min and max. And often I'll hear, what are percentiles? So per Wikipedia, percentile is the value of a variable below which a certain % of observation falls. So I'm taking a short example here. If we're looking for 95th percentile time, we'll take all the responses in a particular time period, and for each of this example, we'll say we have 100 values. We'll sort all the values from smallest to largest, and then we'll look for the 95th element in this list. So in this particular case, the 95th percentile is 0.1 or 124 milliseconds. So what this tells you is that 95% of your requests are faster than 124 milliseconds, whereas 5% of your requests are slower. So that's helpful, and it helps with the average, because averages can sometimes get screwed up with some of these outliers. So this gives you yet another data point. Now I'm showing an actual example where where this validated one of our improvements, where we went through a slow query log and ran a bunch of explains. This is MySQL, and then number of select scans just dropped precipitously, and that also resulted in our 90th percentile times really going down and getting a lot more stable. So we're not having very huge or large outliers for 90th percentile. Now you can go further by analyzing individual URLs. There was actually a tool I wrote, which is a little bit rusty at this point, but I do intend to work on it where you can analyze, by analyzing the logs, you can do per URL analysis, because presumably your site has more than one page. So if you're going to improve the speeds, you should look at what are my slowest pages, and what is taking the most, and just give you a better idea of what is the most appropriate, or what will give you the biggest bang for the buck. Because you don't want to optimize a page that gets 10 requests. You want to optimize a page that gets 100,000 requests, because that's going to yield you way better results. So this tool will provide you with kind of comparison of individual servers, so you can see if for this particular URL any particular server is acting in differently, way differently than some of the other servers, and you can also see if the time performance is time dependent, and this will give you more info, so you could go maybe to your logs and just see, well, why was there such a huge spike at 11 o'clock or so. Now you can also go even further by adding things like what's the size of the request that you receive with all the headers. This is actually a good thing to track, track because you might inadvertently add too many cookies, which will cause the clients to always submit, even for the smallest request, the request might be like 1K or 2K, whereas you're just returning maybe a couple bytes if it's like an AJAX call. So this may not be the most efficient way to do it. So that's why you want to keep track of it. If you're running an a REST API, you may want to just keep track of like posts, puts, or deletes. What I've also found very useful is to keep track of unique IPs, or you can do sessions, so you can track abusers or crawlers, because some are pretty aggressive. It can really degrade your service quite severely. Okay, so beyond just the basic web metrics, we also should really keep track of host metrics, because your applications are not running somewhere in the cloud. They're actually running on hosts, whether they're virtual or physical, and what happens on these hosts will affect your application. So, for instance, I like to usually aggregate all the load averages, because often you will see things more clearly that things are abnormal, and this is load averages. A lot of people think it's a useless metric. I think it's pretty valuable because it will take into account the CPU utilization, the wait I/O, and so on. It's not really it's hard to describe what it is, but when it's bad, it's that it is bad. So I actually have an example here where our database, a primary database server, something happened, and it went into, there were some locks, spin locks that were activated, and the load shot up to about 200, which really affected our performance. I mean, the site was up, but it was like 20 times slower. So this is, it will give you pretty much an immediate indication, that when things are really going bad. So don't stop there. You should add things like storage stats. There's wealth of information as far as how many disk reads and so on you have, or writes, which will help you in a situation like these where things are working happily, and then all of a sudden your reads are taking way too much time, or the writes disappear. And if we didn't have this metric, I would be scratching my head, pulling my hair, just trying to figure out why is all of a sudden everything really slow, and why. I would just not have the understanding why things are bad as they are, because I mean here we just lost our write performance completely. We should also keep track of application memory usage. This is often where people think that you could just, if your site is in trouble, just add more Apache workers. That may not be the smartest thing to do, because if there's any type of database pileup where requests are waiting for the database, things can escalate quite quickly, and you could actually very quickly exhaust your memory, and things will start swapping, and things will get way worse than you thought they were going. Also, database, keep good track of it, keep good metrics. This is also one of the examples I keep. I saw there was a jump in Apache average duration, or the response duration, and then I was trying to figure out, well, what happened, and then I looked in the database, and for whatever reason, the query cache got It'd be like, well, I don't know. Things happen, but at least with this type of information, if you're tracking it, you can get ahead. Also, network. This is something that you should really keep a good track. For instance, especially on proxies and load balancers, you could exceed your network utilization. So this kind of wall up at about 117 megabytes per second, that's your effective throughput of your network card. Once that happens, things are going to be very slow for a number of people because you're exceeding your network throughput. So you do want to watch it. And this one is very insidious because most people don't track TCP loss, but when this strikes you, it's very random because there's nothing shows up in the logs. It's very it's random. It happens very rarely. You will lose your mind looking for it. But if you keep track of TCP loss, it might really get you ahead of the game of looking for problems. So there's always more. As I said, this is just a small sample of things you can monitor. There's a number of Ganglia modules and metrics modules that will allow you to track tons of different things. I would definitely encourage you to do it. Now, a few words about RD because that often comes up. People say it's lossy. And I say it works well, it's been battle tested, and you don't need operational experience to run it. For instance, there's some other technologies that require HBase. You can do it. It's just more complicated. And then client-side rendering of graphs is exciting, but if you have hundreds of graphs on one page, it will bog down. And more about metrics. So how do we get metrics in the first place? You can query existing counters on your network interface. You can query an application, or you can time certain operations. Those are some of the common ways of doing it. Or you could parse logs, as Mike has shown, and we've seen previously. Now, challenges with collecting metrics are that how do you keep track of metrics, especially some things that happen multiple times a second, and how do you measure things that happen on different hosts that you need to aggregate. There's definitely a number of different solutions that you can use, such as Folsom, Greplin, or Scales, or metrics. So there's definitely libraries to use it. However, one thing that I've actually very recently found very useful is to use StatsD, which came out of Etsy, and which allows you to measure things without actually keeping track of measurement itself. So you can have a network daemon that is accessible from any network machine, and which allows you to collect things such as timing metrics, and it will produce average time, max time, min time, 90th percentile time, and if you send in counters, it will generate counters. I mean, that's very useful. So how do I use it? I do have two examples. One example is a Perl example, which is pretty trivial. incrementing a counter when we do a Jira API call, and another one is just timing how long it takes to do a complex database query. I mean, this is something that is very useful, and you should do that. You should definitely find what your complex database queries are, and you should definitely time them, because when things start going bad, this will be your indication. And I do have another. This is a Python example I actually wrote that to actually just time how long it takes to connect to localhost. And as a result, I have this nice graph that shows me the upper and lower bounds, what the averages are, and 90th percentile, so that if you track this, you will know when things are quirky. So you should make a bunch of these graphs that track performance of some of the key things you do, and then just learn what's normal. What are the normal ranges? And what can you do to spot trouble? So I was going to do a Ganglia demo, but I think we're running out of time. So I don't know if that's.
Yeah, I think it'd be good to hit some questions. Would be really good. There's a lot of decent talk on the chat about RD and StatsD, and there's one question in here, which is maybe you'll get here, but how do you monitor server integrated partner APIs? Presumably that's from Ian Withrow. Presumably he's talking about external API calls outside, so I guess basically a non-node specific but application specific metrics into the systems that you maintain.
Well, I think in the past, we used libraries, some of the built-in Java libraries to keep track of counters. So, for instance, anytime you make a call to an external API service, I mean, similar to the example that I showed with the database query, I mean, you should do the same for external APIs. I mean, that's a great question, because you really should track, when. How long it takes for you to connect to an external API service, how many times do you do that, so that you know what's normal, and if your site requires something from an external API, that when they slow down that's a problem for you. So I think I would personally at this point just recommend StatsD, because I think it's fairly easy to set up, deploy, but that's not the only way. You can just keep track of it yourself by just having almost like internal metrics tracking in your application.